The first classification algorithm we're going to look at is the logistic regression. But first, let's go and load a data set. Now, for this task, we're going to use diabetes, which is a binary classification problem. We can also use Anosphere. So let's go ahead and load that. So already we can see we have 9 attributes and we have 2 distinct classes, right? Again, one thing you'll notice here, we have an imbalanced data set, meaning that the negative class kind of dominates the positive class. So this would be a good candidate to look at other evaluation metrics like ROC curve or PRC curve. Okay. So click on classify. By default, we already see we have 0R, which is just an algorithm that we use to for baseline performance. So click on start here, the default setting. So already we can see out of 68 instances, we were able to correctly classify 500. So other classification algorithms, if they perform less than this, then usually this will perform worse. So the next thing I want to talk about here, the default test option here is cross-validation false equals to 10. So cross-validation, basically, we partition our data set into, so for example, here, if I just say 5, right? So what that means, we partition our data set into 5 folds, right? So we use the first 4, okay, first 4 for training, and then we use the last fold, we call these folds, right? And then we test that data over here, okay? And then we do that 5 times. So again, the K here, this is what we call the K fold cross-validation, and K here just means the number of folds you want to have. So you split the data set into the number of K folds. In our case, here is 5. And the next iteration will be just K minus, so this is K minus 1. We use the 1 for testing. And then we get the score, validation score. We save the validation score once we test the performance of on the training data on our test set. And then we save the validation score. Then we go to K minus 2 and do the same. So we iterate this 5 times, each time getting the validation score. And then we summarize the skill of this model by getting the average results for all the score. Okay. Now, cross-validation is just a means to get a more accurate measure of the performance, okay, given some new data, okay? So another thing here we can do is to choose the logistic regression, which is under functions. So let's go to functions, click on logistics, and you can actually configure this. So these are what we call hyperparameters. So we could change this to 50, 100, or maybe 150. This is just a hyperparameter that we use for tuning our model. Okay, so it just tells us how many training samples do we want to include in a batch size here before we iterate through the training for the next training samples. Okay, all right, so we'll just take that as default, and we can leave this as 10. Okay, so click on start, and we can see already. So we will correctly identify 593. That's 77% accuracy. So compared to this, definitely performs better. So as our baseline performance, so that's okay. Another thing we need to look at is the confusion matrix. You can see here 175 instances were incorrectly classified. Okay. Again, we can play around with this. We can change this maybe to 5. Click on start and see whether it kind of improves. So if we check again here, you can see actually kind of just improve a little bit. But since our data set here is imbalanced, so we can't really rely on the accuracy. So we want to pay attention to the ROC curve and the PRC area. Okay. To actually see how it performs here, we can click on visualize threshold curve. We can look at each of these class, tested negative. You can see here the goal here with ROC curve is the further it is to the top left corner, the better the performance of our model, right? So the coordinate here 1, 1. So again, as you can see here, ROC curve, basically we're just plotting the TP rate on the x-axis and the FP rate on the y-axis. Okay. Similarly here, if we wanted to see the PRC area, basically here we just want to plot the recall. Recall will be on the x-axis. PRC just means precision and recall. And then the precision here will be on our y-axis. And you can see here, the goal here is to, it's just opposite of ROC curve. So the farther away it is to the rightmost corner here, 1, as well, the better the performance. Okay. So if we go back to the ROC curve here, another thing we can see is that, so I'll pick tested positive, right? So we can see here, if we draw a line here, diagonal here, right? So if our model is close to this line, imaginary line, diagonal line here, that means the performance is really bad, right? If it's on this line, it just means our model is nothing more than just flipping a coin. Okay. All right. So again, we can fine tune this a little bit. We can say maybe we want to increase this to maybe 150, right? And we can probably reduce this to maybe 3 cross validation. Click start. Then you can compare and see how the ROC and PRC compares. So if you compare with the previous, you can see there's a marginal improvement. Actually, it just remains the same. So you can play around with this parameters here, and also just changing between 550, 100, and 150. Another thing you just need to keep in mind is that to also improve the performance of your model, again, you need to take care if you have any missing values, for example, in your data set. So you need to take care of that and do some data pre-processing. So for example, in our data set here, we can see we have some instances of zero pressure and zero mass. So you want to take care of that. Other techniques you can use is to do some standardization and normalization, and then you can come back here and run some of these classification algorithms and see whether that's going to improve your performance. So in summary here, logistic regression is just a statistical model. Sometimes we call this a logit model. And we use this for classification and predictive analytics, right? So again, this is just a logistic, it's actually a supervised learning algorithm that we use to predict a dependent categorical target variable. So in our case here, if we go back here, you can see our class here. This is our categorical variable. We see the tested negative or tested positive, okay? So, and then of course, this logistic regression here just estimates, we use probability, want to find the probability of an event occurring, right? So in this case, this is a Pima Indian data set. So what's the probability of a patient getting diabetes, onset of diabetes in the next 5 years? Okay. So in our next video, we'll look at other top 5 classification algorithms.